Okay, sorry about that. I had a whole system crash. I had to recover the whole thing. Anyways, dang it. Somebody was asking that I share my code. Let me do that. When I see that there's a couple questions that are lingering as well. Okay, cool. Somebody's asking, what are some good ways to add elements from a tuple into an existing dictionary's key value pairs? And we have an example thing here. Code wasn't in replit from another document. Formatting is all messed up. Okay, well, let's just see. If the formatting's messed up, I'm going to have to take liberties, so it might be hard to troubleshoot accurately, but we'll see. Oh yeah, that's definitely that's definitely not formatted at all. Okay. I'll just do this. I'm gonna guess this is how you had it. I don't know if this went here or here or here, or if this went here or here or here. So I'm gonna just kind of guess that it was, this is what you had. But yeah, that's the problem. You need to, when you paste in code, you need to make sure that the spacing is formatted correctly, because I actually have no idea if the spacing isn't retained. I have no idea what your original code was, really. So I'll do my best with this and kind of go off of this. So the question is, if I wanted to include elements from tup1 into dict1, how would you go about this? Let's see then. So we've got this tuple, and we want to include these. It looks like the tuple contains key value pair like elements, or it contains elements in a pattern that sort of mimics key value pairs, in a dictionary. So the question is, how would we populate this dictionary with the elements from this tuple? This is a little bit, there's kind of a, in terms of the way this question is asked, it's sort of framed as a general, like, how, like, what's best practices, or like how do you do this? And it's not that it's not possible, it's just the way that it's framed, or the way that the framing comes through to me, makes me think like there's kind of not, there's a disparity is what it is between these two types of data, right? And that means there isn't just like a direct sort of easy compatibility between them. So yeah, I think it would just be sort of a, like a manual process, just very kind of like, depending on your data structure, you have to figure that out, right? Because the question, how do you populate a dictionary with elements from a tuple? Right? I'm paraphrasing that, but that was kind of the gist of it. That could look a lot of different ways, and it all just depends on how that data is structured, right? In this case, we're not the key or the indices from the tuple aren't going to be reflected in the dictionary at all, right? And with a different data structure, that might be, or that might not be the case, right? We might want to use the indices from the tuple in the dictionary in some way. Maybe set those as the keys or something. So yeah, at any rate, it's pretty clear with this. We want to put the key C, D, B, and H with the values associated with those into the dictionary. So I just wanted to kind of provide that context to make it clear, like, I can answer this question in terms of this specific data structure because that's what's in front of me to do, but like, don't take it as a like generalized rule, because there kind of isn't a generalized rule for this. This would just be a case by case thing, kind of. So let me just see what you have going on here. Let me kind of get everything spaced out here. Okay. And if this is from a challenge in Learn, if you can provide a link to that, that would be helpful as well. So I'm just going to start over with this one and just kind of show how I would do this. I'd probably do like D equals dict 1 dot copy, and then I'll modify D, and then I could go through. I want to go through the tuple in sets of 2. So I could do a range, get the index, and do like every other number. I could do a range of range in steps of 2, and that would give me every other number. That means I would have the key, the index of the key from the tuple. That'd be one way. Or I could do a zip, which feels a little better to me. So I could do I'm just going to call this KV in zip, and I'll pull apart this tuple. Tup1 sub. Oops. We'll do tup1 and we'll slice it in steps of 2. And then we'll do this. We'll start here. Is that actually going to do what I want it to do? Let's see here. I'm just going to print K and V. And by printing K and V, I should see this C22, D22, B23, and H25. So C22, D, B, H25. Okay, good. So that confirms that's going to give me what I need for that tuple. Then from here, it's pretty straightforward. It'll just be D sub K equals V, and then we'll return D. Just like that. Now, it does occur to me, I might could get lucky on this, and I kind of think I can cast this zip as a dictionary. Let's see, I sure can. That actually does work. And in this case, what I want to do is I'll say d.update. And I think I can just pass that in there. Of course not, yeah. Say d.update, oops, 2 dots. Try that. And that will do it. That'll do it. Okay, so in this case, I kind of forget that I can do this sometimes. But what's happening here, I've got this zip, and since I'm zipping something that has this, like, how do I put this? Let me show you what this zip is doing for me. So we can kind of, let's just ignore everything else for now. And let's just look at this. Well, I need the dictionary actually. Nope, I don't need the dictionary. So we'll ignore everything else and we'll just look at this zip. So I print this zip. I'm not going to get anything interesting. I get a zip object with a address. What I can do with zip, though, is cast it to other things. I can cast it as a list. Since it gives me a generator, let's do this. So I'll cast this as a list. So you can see when I cast this zip as a list, I get a list of tuples where each tuple has 2 objects in it. And in this case, this list of tuples kind of has a structure reminiscent of a dictionary. I happen to know that this structure is what I get when I cast a dictionary as a list, and I'll show you. If I do, I'll just do this d equals d1.copy. So if I print list, d, so I'm going to cast d as a list. Oops. Oh no, excuse me, d.items. That's what I meant to do. So if I do d.items like this, that's going to give me the key value pairs in tuples, and I get this list of tuples again. So this data structure is kind of a, I feel weird putting it like this, but it's sort of a canonical analog to a dictionary. You'll see a lot of times this sort of list of 2-part or 2-piece tuples kind of as an analogy to dictionaries in certain cases. And there's certain cases where a list of tuples like this is advantageous. For one thing, it retains an order because it's a list, right? Each tuple now has an index, right? So you could change the elements around in a different order if you needed to do that. So you can sort of think of a list of tuples in this way as sort of a raw dictionary, if you wanted to think about it that way, or more raw version of a dictionary. That's a little bit, it's a bit reductive. I mean, it's really just a different data type, but that analogy pops up enough in Python that I know when I see something that is a list of tuples or can be easily converted to a list of tuples, I automatically think, okay, I can turn that into a dictionary. So in this case, with zip, instead of casting this as a list, I can just cast this directly as a dict, and it works just like that. Then I can use this dictionary to extend this dictionary with .update, like so. Now, if I try to return this, which I did try to return that initially, and I got none. And that's because update, you might have tried to do this with like list.append, where you try to return or print an append and it prints none, it gives you back none. So this is a mutable update is a mutable method for dictionaries, just like append is. So its job is not to return a value and give you a value back. Its job is to change the value that you call it on. So we're calling it on D, which is a dictionary. Dictionaries have the update method. The update method updates, mutates the dictionary we call it on. So we'll call update and update it with this dictionary of these zipped items, so this zipped tuple. And then that will change the dictionary, and then we'll return it. Cool. Hopefully that helps. Cool. All right. Let's see. Sorry, I'm still a little frazzled from that system crash that I had. But yeah. Let's see. We got another question here regarding this. Somebody's asking, what is tup1 sub : 2 and tup1 sub 1 : 2? So this is slicing is what's happening here. We have some material on slicing. How would I put this? I think about like with tuples, lists, strings, you have concatenation, slicing, and indexing, and these are three really, or I say indexing, it's really subscripting. It's called subscripting, but I use indexing, so I use the word indexing so I can remember CSI, which is like that, like CSI Miami or something. It's just an easy acronym for me to remember, CSI. And those are my sort of indexed or quote unquote ordered collection manipulation strategies that are universal. So if you understand concatenation, slicing, and indexing, you can kind of do whatever you want with a collection, whether it's mutable or not. And then lists being mutable obviously have additional mutable operations that you can do, but you can mimic those with CSI. So what this is doing is giving us what's called a slice. So a slice is just like a subsection. Here, I'll show you. Or I guess I don't need to do it here. I'll do it. I'll just use that same tuple and I'll do a whole new section so we don't get it confused with other things. Slicing. So here's our tuple. Let's print off the tuple, tup1, and then let's do, we'll print off a slice of it. So, oops. So a slice of this tuple, well, first of all, let's just look at indexing. So if I want to get one of these specific elements, I can just find the index, right? Like B is at index 0, 1, 2, 3, 4. So if I do tup, I'm just going to call this tup. If I do tup sub 4, I'm going to get B, right? And if I do tup sub 5, I'm going to get 23. Pretty straightforward. So with a slice, I can tell it, give me a tuple, another tuple that starts at one index and ends at another index from this tuple, right? So let's say I wanted to slice from 22 to B, right? So I could do index 0, 1, so that'll be my starting index. And then my stopping index will be 4. Now, the stopping index is excluded. It's up to, but not including. So if I do this, I'm actually going to get start at this 22 and end just short of B. So I want to do +1 if I want to include that one, right? Obviously 4 plus 1 is 5, but I'm going to do 4, instead of saying 5, I'm going to do 4 plus 1 because the +1 to me says 4 inclusive. So it's just a way of keeping it descriptive. Cool. And then, so if we look at this, when I put in these colons, let's just show it like this. When I put in these colons, it sort of makes 3 partitions in that I can put something in. If you can actually, if you just want to do start and stop, you can just do 1 colon. I always do both though, whether I need the second one or not. It's just a personal preference. But usually if you see like a slice that just start and stop, like I just showed, like 1 to 4 plus 1, like that. This is what you'll usually see with only 1 colon in there. But if I have 2 colons, it sort of makes 3 partitions. And this first partition is the start. The second, well, not the partition, but the first section created by the partitions is start, and then the second section is stop, and then the third section is what we call step. And the step is the number of indices to skip. So by default, if I don't specify a start, it's going to assume 0. Let's do this. So actually, let me do default. So the default will be 0 for the start. The default stop is len tup plus 1. Or actually, it's just len tup. That will take it all the way to the end. And the default step is +1, right? So if I don't specify any of those, it will assume these values specifically. But I can specify a different step, right? So if I did, say if I did -1, you think about what that would do. So rather than going in steps of, or let me try to get it oriented right with the camera, of +1 from right, excuse me, from left to right, it'll do steps of -1 and it'll go backwards, right? But in this case, what I'm doing is I'm doing steps of 2. So if I slice this tuple, let's just do something like this. From beginning to end, which is what this is saying. From beginning to end, I'm not specifying a start, so I want it to start at 0. I'm not specifying an end, so I want it to end at the end. And I want to go in steps of 2. This is going to give me every other, this is going to be a slice that contains every other value, C, D, B, and H. So essentially, this is my keys. I could say keys. Like this. Oh, I'll be consistent with my spaces there, sorry. And then if I start at index 1, then this is going to be my values, 22, 22, 23, and 25. So vowels will be index 1. We could do it like this. So keys is starting at 0, going to the end, and steps of 2. Vowels is starting at 1, going to the end in steps of 2. There you go. Hopefully that's helpful. Oops. Dang it. Let me know if that answered y'all's question. Okay, we got a question about dictionaries. Great. Oops. Go away. Cool. I'm going to copy this link. Pop this in here. Okay, and for context, we've got a little code and a little comment with this. So this is the person's code to say they're getting this error, list object is not callable. And this is, I think, number 3. Yes, okay. I'm going to put in the problem copy here. Okay, please write a function called accumfunc that takes a list as an input. This function should return a dictionary containing keys representing all the different items in the list and values representing the number of times that that key occurs in the list. Please call your function accumfunc. Okay. So let's see here. I see. So when Python thinks of something as callable, a function is callable. When we talk about a function call, we're talking about a function being invoked. So this is what a function call looks like. Print is a function call, right? And I'm actually I'll call that function that you're writing. This is a function call, right? So if we look here, we have accumfunc takes in list. Here's your accumulator. For I in list LST, which is a list, remember? And it looks like it's got these parentheses after it, so Python is like, oh, well, I'll invoke that or I'll call that like a function, or invoke it like a function. But it's not a function, it's a list, right? So we can't do list equals I'm just gonna fix some of these really quick. Oh my gosh. Okay. So we just got a list of numbers, right? So I can't have a list and then LST like this, right? Because that'll give me the same error for the same reason. I mean, essentially, it doesn't look like it, but this is what's happening. Oops. So if I try to run that, I'm going to get that same error. Type error list object is not callable. Does that make sense? Let me know if that makes sense. I know there's a bit of a delay. I'll keep moving on, but yeah, let me know if that makes sense. So from here, I think we'll just remove those and let's just see if it works. Oh, oops, that's me. In my list, name item is not defined. So this will be I. Oops, like that. Okay. Looks like it works. So you can either rename item to I or I to item. Cool. Yeah, you're welcome. Awesome. I'm going to put another minute on the clock. I don't see any questions in here right now. Yeah, I'm just going to put a minute or two on the clock, give you all a chance to put in a question. All right, cool. Looks like we got a question. All right, challenge number 3 of this week's weekly challenges. Okay. I'm going to take these. I'm going to put them here. And we'll do this. That's our expectation. This is our res. Just like that. And then for each of these, we'll do print res equals exp. Okay, so if you've ever seen me do anything, you know what I'm doing. But just for context anyways, I'm making tests. Anytime you see these 4 examples, these are basically complete or almost complete tests. Now I just like to write them up like this. Res is short for result, exp is short for exp. You don't have to call them that if you don't want to call them that. That's just what I like to do. So I like to do res equals exp, and this will tell me true or false whether they're equal. If they are equal, then I know it's working. And then I always like to print the res as well. That way, if they're not equal, I can see the result that I actually got. So the result is the result of the function call that I actually got. And I'm just kind of looking at this. A lot of times you can kind of tell what it's supposed to do just kind of by looking at the tests, you know. So I got this 3, 2, 1, 0, 5, 6, 4, 0, 1, 5, 3, 0, 4280. Okay. And then this is 1230, 1350, 2480, 4560. Interesting. I wonder if it's significant that the input has these zeros spaced at even intervals. Yeah, anyways, I should probably read the problem statement. That'll make more sense. Okay, so write a function called sort sequence. Def sort sequence. It looks like we're going to take in a list. Yeah. And I'm just going to pass for now. Okay. Write a function called sort sequence which takes in a list of numbers. This function should split the list of numbers into subarrays on the number 0. Okay, well, I guess it is significant that the input has those evenly spaced zeros. So that'll be easy. Split on zeros. Oh, it's interesting, but does the subarray include the 0? Okay. I guess we'll find out later. So, let's see here. Split the list of numbers into subarrays on the number 0. Sort the subarrays in ascending order with 0 at the end of each one. Okay. Sort all of the subarrays in order smallest sum. Oh, cool. This is going to be fun. Return a list with all of the subarrays in the correct order. Cool. I'm going to call this in list, and we'll do my output is just going to be called list. Be an empty list like this. I may not need an accumulator, but I probably will. So I'll just assume that I do. One thing that I notice right away, I've got this kind of split and join behavior. So it says split. So I can split a string into a list, but I have a list. If I turned the list into a string and then back into a list, I could split it accordingly. So let's try to join the list into a string and then split that string back into a list split on zeros. So let's say I'm just going to do this inside of a print just so I can kind of play around with it. So I'll say in list dot, oops, nope. I still always do that. So I think I need to split on a space here, and I'll show you why. Dot join. So if I don't split on a space, sort sequence is not defined. Oh, interesting. I should go fix that. That's a bit of a typo. Oh, very interesting. Oh yeah, of course. So I can't join a list of numbers. I can only join a list of strings. So I'm going to map stir to each element in this list, which will convert every element to a string individually. And see, so now I get this monster, right? Now this is all the numbers in the order that they were shown in. But it's not really. Let's see here. Oh, that's what's happening. Yeah, sorry. I got confused. Okay. It's not really useful to me like this because it's they're all mashed together. So I do want some separation so I can have something to kind of split on later. So this gives me a string of number characters separated by spaces. Now, the reason that's interesting is because I can make this a subarray, a list of subarrays by doing split on zeros. We'll split on zeros like that. And then we can do, so now we have a list of strings. I'm just going to call it stir list, and I can say for stir st. I can't call it stir because stir is a keyword. For, let's call it text in stir list. Let's print text. Okay, we've got some spaces and stuff in there. So let's actually split this on spaces. Let's try that. And look at that. Now I want to actually list map int. And there's my subarrays. So instead of list, I can just do sorted, which will give me a list anyways. That'll convert it to a list anyways. And okay, and I might just append this list.append like that. So now I've got a list of sorted lists. I've got this empty one just dangling out here. I'm not sure why that is, but I guess that's okay. We will figure that out later. Yeah. I think I could. I think I could just do this. I could say for list ls in list. Let's call this lists list. Okay. Lists list for list in lists list. Okay. We'll call that ls, and then this will be lst. Okay. I know this is silly. We'll call this ls1, or no, we'll just call that ls, and then we'll say for l in ls, lst dot append l. I'm skipping a step here, I just realized, but we'll come in and fill that in a second. And then I think at the end of each of these, I'm gonna list dot append 0. Let's try this. I think I might end up with an extra 0. I sure do end up with an extra 0, so that's unfortunate, and that's because of that extra empty list. I really want to find out what that's all about. So I'm just going to go through and start printing things out. Not quite sure why I'm getting that empty list, because I got that empty string there. Got that empty string. And then, so I guess I could just say if, let's just print a list of text. And the reason I'm putting this in a list brackets like this is just so I can see the quotation marks. It's a little trick. So that indeed shows me that one of the elements in here I'm iterating through is just empty. So I think I'm just going to do something simple. I'm just going to say if I could say if not text. Why would I do that? Gosh, my brain is silly. If text, just if text. Yeah, if text, which just means if there's something in it. But I think what I want to do, if text not in, and I'm going to do a tuple containing empty string and string with a space in it, just in case, because I think, I'm not sure if I can actually end up with this, but I think if I did, it would give me the same problem. So in either case, I know that this is an invalid string. I'll just check both of those. So if as long as string isn't empty or has a space in it, then I'll do the append, and that's going to save me that extra 0 there. Okay, cool. So that's pretty cool. So I have the sorted list here, and this is sort of my what would you call this? The let's just call it a sorted list. We'll call it sorted list equals this. And what I really want to do is I want to append a tuple of sum sorted list and sorted list like this. And the reason I want to do that is it'll allow me to sort. See, so that's messed me up here, but that's okay. I'll have to deal with that. It's going to allow me to sort the lists list. So I'm just going to say sorted lists equals head lists like that. Okay. I'm gonna have to come back and redo that. And let's just return this for now. Okay. So you can see that it sorts the tuples by the first element, right? So that's how that's gonna work. And that's the sum. And I think I want to get back to this, yeah. This will say let me say print ls. Okay, so ls is now a tup. So we'll say tup. We don't need to do tup, we'll just do blank, comma, ls. And then that'll be, yeah, that's what I want. So that'll give me ls. I don't really care about the first thing anymore. I want to iterate through sorted lists. And we'll get rid of that. Go back to this. And I think that's gonna, oops. I think that's gonna do it. True, look at that. So true, that means it's passing. Let's see if my other one passes. True, they both pass, cool. Wow, I thought of this, I feel like I could make this simpler. I kind of doubt that I need to do this like first stage of looping, second stage of looping thing. I have this feeling that I could reduce that down to like one set of iteration and one accumulator, but you know, working code, you can always go back and refactor. We can refactor too. Meh. Okay, that didn't work anyways. Let's see why it didn't work. Interesting. So I must have forgot somehow. So this is saying 1, 2, 3, and this one's expecting 2, 2, 2. Well, that's quite interesting. I wonder, did I... So this is 1, 2, 3, 6, 2, 3. So this is also 6. Oh, wow. Wow, so these are equal. Oh my gosh. That is a very strange thing. That is a very strange thing because the sums of these are equal, right? So I guess if the sums of 2 are equal, I have to, I have to switch the positions by I wonder if that's just the way that this particular test came out. Like they wrote it differently and theirs just happens to do this in a different order, because 1 plus 2 is 3 plus 3 is 6. 2 plus 2 plus 2 is also 6. So these sum to the same thing. So it's just like kind of 6 of one, half a dozen of the other. But I'm not sure if it says what I should do in that case. Let's actually kind of look through this. Right, if it takes a list of numbers, this function should split the list of numbers into sub-arrays on the number 0. Okay. Sort the subarrays in ascending order. Is this, like, it seems like my way is actually more of an ascending order than this way. Yeah, I would say it is, because the default behavior, if two things are equal in that tuple sort that I showed, it's going to go, you know, to the next item and see which one of those, if they're different, and it'll use that as the sorting handle. And in my way, 1 is lower than 2, whereas in the test way, 2 is higher than 1. So I would say mine is more ascending than the test. So I'm calling that a win. But that doesn't really solve the problem of how do we get it to just pass the test. Sort the all. Oh, that's a typo. Sort all of the subarrays in order of smallest sum. Okay. Return a new list with all the subarrays in the correct order. Okay, interesting. Very, very interesting. We have another one that's failing here. First differing element, 6 and 64. And I wonder what that one's, how this one's failing as well. Oh, so that's really interesting. We kind of have a similar error here where the two lists are different actually. So in this one, we've got 6 and 0, right? So 6 and 0 is going to be a smaller sum than 64 plus 73 plus 92. So I don't understand. That seems like it should be good to go there. I guess this was just released today, so I might go hit up Remy and ask if maybe there's just an honest bug in this one. That's kind of funny. I think I'm just gonna have to look up the solution for this, because yeah, unless I'm just totally like off or something. So let me just grab this from our repos here and kind of look at the solution. Yeah, it does seem like 1, 2, 3 would go before 2, 2, 2. Yeah, let me just look at the solution here. Oh, interesting. So they're taking a very different tactic, different approach to this. I'm gonna save this code. Actually, I'm just gonna do this. Let's just copy this whole dang thing. Okay. Take 2. List equals list. They're doing a. Where is this? Where is new? Sorted new key. Oh, interesting. Interesting. Okay. And okay, so we'll have, I'm just going to call this, we'll call this list. Temp be another list. Yeah. And then we'll do out, which will be another list. And we're actually going to return out. Okay. And then this will be for num in sequence. It'll be in list. Or num in list. We're going to say if num equals 0. I'm going to pass for now. If num's not equal to 0, what I want to do is temp.append num. If it is, then we're going to say temp equals sorted temp temp gets sorted temp, and then temp dot append num, because num is 0. We could, it'd be the same, did just do this, but we'll do num. And then we'll say list dot append temp, and then we will reset temp. We'll say temp equals empty list, and the whole process can start over again. Then our out list, we're going to say for sublist in for sublist in sorted list. Oops. We're going to use a special feature in sorted. I don't tend to use this that much, but I really should. We'll just make a lambda function right here. So what this is saying is this key is sort of the thing to sort on. And it allows us to run some process on each element in the list. This lambda is a little function. X is going to be, I mean, we can call X whatever we want, but it's whatever we call it, it's going to be the element from the list. So, or it's going to be the element from this list, which happens to be a sublist. It happens to be another list. We're going to do sub. We're going to sum that, and then append it in. Then I'll say out dot extend sub list, just like that. So this is also true. This does work as well. Let's try that out. Okay, that one works. And that's really interesting because the thing doing the sorting is the sorted function in this case, and in the previous case. Yeah. Huh. I wonder if I could just do list extend here. I wonder if it's something like that. That's really interesting because to me, sorted is doing essentially the same work, but it must be this something to do with this key that's giving it a different result. That's still gonna fail. That's the same failure, and that's the same failure. Wow. Yeah, so there's something that's a really, really, really interesting result. There's something in the way the sorted function works with key like this, because to me, this essentially reads the same as sorting a list of tuples like this. Like to me, that should be the same, but there's something internal in the deep inner workings of the Python sorted function that gives this a different behavior than the other one. And this question was written with sorted using the key parameter, default parameter, or keyword parameter, excuse me. The keyword parameter in the sorted function. So this particular question was written with this in mind, and it just happens to work differently than the other way of doing things. So I'm not sure why that is. I'm gonna have to research that. When I find out, I'll DM y'all and let you know, because that's pretty interesting. I would have thought, this behavior and the key equals lambda x would have been the same, but evidently not. Cool. I will bring this up with Remy and just see what his intent is, and perhaps if we can clarify that a little bit. Because I think it's a cool question either way, but maybe mentioning some use of the keyword in sorted, or something about sorted, learning about sorted. Link to the documentation. That might be really cool in this question. Cool. Yeah, you're welcome. Hopefully that was helpful. That was fun for me, even though I had to look up the answer because I was like, dang, I thought that would work. I did. It's funny because I even did think I could use the keyword in the sorted function, but I was like, no, that's the same as what I'm doing. I'm just kind of doing it in a more manual way, but evidently it is different. So I didn't know that. All right, cool. This is our normal stopping. Well, we're quite a bit past our normal stopping time. I usually stop at 5:30. It's 5:52 right now. I do see somebody has a question in here. Oh, okay. We got one more question. It says a small question regarding for loops. For A, B, and tup1, when we add arguments, we can take this one more. This will be our last one. This seems like a quick one, I think. Okay. Okay. So when adding two arguments, A and B, into the for loop, it goes into the nested elements. Yep. So we have a tuple of tuples. We're iterating through that, and this would give us a tuple back, which we can pull apart in the loop like this. It goes into the nested elements and prints those two elements within. Can you explain what the computer's process or logic is behind this? Phrased like this, like makes me think of that you might want an answer like regarding like what's happening on the hardware level. I'm not sure. This isn't really. We're not really like. Yeah, I mean this is just a feature built into Python is what this is. So if I say, let's say I have this. Oops. God, come on. Okay. We'll say tup equals, or how should I do this? Okay, let's say I have a comma b equals 3 comma 10. So this is called unboxing, sometimes called unboxing or unpacking a tuple. So in this case, it doesn't quite look like it, but this is actually a tuple. It's whether I put parentheses around it or not, it's a tuple. And I could prove this if I just say a equals 3 comma 10 and print a like this. Oops. Print a. I get 310, right? So a equals 3 comma 10. There's no parentheses around it. It doesn't matter though. With or without parentheses, it's a tuple. Python knows it's a tuple. But I can unbox that tuple by doing a comma b equals 3 comma 10. And that just pulls it apart. And this is such a consistent mechanic. Anytime you have the opportunity to assign an identifier to a tuple, I think with the exception of a parameter in a function, but anytime you have the opportunity to do this, to assign an identifier to a tuple, aside from a parameter in a function, you can unpack it, right? So here we're making a variable and we can unpack that variable. And here it's the same thing basically. We have an opportunity to give each of these. See, this is called tup. I'm going to call this list. I'm just going to make this. Well, that's kind of confusing. I'll call this array. We'll call this array because lists and tuples are both kind of like arrays. So if we look at this, right, this is a tuple of tuples. Okay. So for a, b in array, I could do for tup or for a, or whatever. I could just do one name here, right? But since it's a tup, since it's a tuple in there, I can actually unpack it a comma b, a comma b. I can unpack it in the for loop. So that's just a feature that's built into Python. And anytime you see this in a for loop, this sort of a comma b like in enumerate gives back a tuple for every iteration that it gives. It gives back a tuple. Zip also gives back a tuple. A list of tuples or a tuple of tuples gives back a tuple. Dictionary.items gives back a tuple. Same deal, right? In all of those cases, we have this for a comma b kind of syntax. In enumerate, we usually call it for index and value, and in zip, we give it whatever names, and in dot items, we'll do key and value or whatever. But it's always the same thing. We're always unpacking a tuple in those cases. I feel like that doesn't unpack. Oh yeah, okay. So this person is saying, yeah, a comma b won't unpack this tuple of tuples, and that's true, right? Because I mean, there's an added level of complexity because this is a tuple of tuples. But if I do a comma b equals 3 comma 10 comma 4, this is going to give me a problem, right? If I a b c, if I try to unpack 3 things from a tuple that has 2 things, it says not enough values to unpack, expected 3 got 2. And if I try to unpack 3 things from a tuple that has 5 things or 4 things, it says too many values to unpack, expected 3. So in any case, this is something that's consistent about unpacking. You have to know the number of elements in that you're unpacking, because you have to write them in. There's no way to unpack it dynamically unless you're just like doing like tup, but then you're not unpacking anything, you're just saving it into a tuple, so in this case, when we're unpacking something, in any time we're unpacking something, we have to know how many elements are in it, right? So if we want to unpack a tuple, each tuple that's inside of another list or another tuple or something, we can do that one inner tuple at a time with a for loop, right? One other way to think about this is you could do for tup in array, and then you could do a comma b equals tup, right? And we could prove that print if I print tup, I'm just going to get those tups, right? And I could unpack each of those tups like this: print a comma b, same deal, right? But I don't like Python just makes this easy. It's like, well, if you're going to iterate through an iterable of tuples, a list or a tuple of tuples, we'll just let you unpack it in place right away. And by the way, this works for lists as well, but you don't tend to see it as much with lists since lists are mutable, their size can change. So you don't have the same ability to guarantee the size of a list like you do with a tuple. If you've constructed your data correctly, your tuples will be the right size, but if you've constructed your data correctly and you're using lists, things can still change those lists, so you can't really guarantee the size in the same way that you could with tuples. So you tend to see this with tuples because since you need to know how many elements you need to unpack, it's useful to have to think about unpacking a data type whose size won't change in a way that you don't expect. So that's why we see it with tuples. Great, glad that was helpful. Cool. Well, sorry about the technical difficulties. I am trying to find out what's the cause of that crashing issue. I think I might have located it this time. I will figure it out eventually. So hopefully we won't be having any more crashes during study halls. But thanks for hanging in with me and hanging out. Thanks for everybody who asked a question today and interacted. I think that's really brings study halls alive. I feel like study halls have been going really good lately. I'm really excited about where they're at, and that's thanks to you all and your participation. So do feel free to come back and bring in all your questions that you want. Don't be shy putting them in. If I get a big old flood of them, then that's great, and I'll have plenty to work with. So yeah, I hope to see you all in the next one. Just a quick update. Tovio is going to be out of town this week. As it happens, I have a lot of team members that are taking vacation around this time. My manager is, and Tovio is, so I'm going to end up taking some days off here. So I'm going to cut one study hall. It's probably going to be Friday from the rotation this week. So there's only going to be one more study hall this week. I haven't decided which one yet. I will update you all as soon as I know. So as soon as I make that decision, I'll have a decision by tomorrow. And then next week, Monday is a holiday, and then normal city hall hours will resume as of Tuesday, so the following Wednesday. So it's a little bit up in the air, so just be prepared. Keep an eye out on the channel for updates and schedule changes if there are any. So, yep. If you're in premium prep, I'll probably see you in there. I'll probably drop by for like the last bit of class, just to say bye to everybody and just see y'all off. And feel free to defer into the next one, next premium prep, if you want to do that as well. And yeah. Cool. Don't be a stranger. Feel free to reach out if you have any questions, if you want mentoring, and look forward to working with you all soon. Cool. Bye-bye.